Good afternoon. Little video on gas laws for EMS and how they affect our patients. All the air above you has weight, and that's called the atmospheric pressure. The total of this atmospheric pressure is about 760 millimeters of mercury when you're at sea level. So think about all of that air weighing down on top of you. It's about 760 millimeters of mercury pressure on us. Boyle's law says that pressure and volume are inversely proportional. So if we increase the pressure, we'll decrease the volume. For every 33 feet of water that a person goes down, there's an equivalent of another 1 atmosphere of pressure weighing down on them. This is important when a person is going up. If they hold their breath, as they go up, they'll have less and less pressure on them, and their lungs, like a couple of balloons, can expand, and if they don't let that pressure out, will actually rupture and can cause a pneumothorax. Dalton's law says that the total pressure is equal to the partial pressure of each of the gases. So we know the atmosphere is about 20% oxygen, 79% nitrogen, 1% other gases. And if we look at that 760 millimeters of mercury, we know that about 20% of that is 152 millimeters. So the partial pressure of oxygen is 152. Nitrogen 600, oxygen is 8. Other is 8. Add that up and it's 760. Now the total percentage never changes, but the pressure weighing down on you does. So if you go higher up in the mountains, you'll have less pressure. So let's say, as an example, we have 600 millimeters of mercury weighing down on us. The percentage of oxygen that is part of that is still 20%, which is 120 millimeters of mercury. Nitrogen is 474 and other is 6. This is what becomes real important when somebody goes high up into the mountains and why they need oxygen. They don't have the total amount of pressure weighing down on them like they do at sea level. So they bring a little bit of oxygen with them to help them. Henry's law says that the amount of gas dissolved in a liquid is proportional to the amount of pressure on top of it. So if we had some oxygen dissolved above some water, simulated by the yellow circles, as we increase the amount of pressure, we will push more of the oxygen into the water, or in this case, the bloodstream. Now, the reverse of this is true, and perhaps more important to us. If a person were to come up too quickly, there would be less pressure on them and less pressure on their blood, and the oxygen would begin to come out of it. And this happens with nitrogen too. In fact, it can form a large bubble, which then can cause the bends, usually in the joints, could also cause something in the brain similar to a stroke.